I'd like to show you how to do an inverse normal on your calculator. So the first thing you want to do, of course, is turn this on. And then the next thing that we want to do is we want to go to the distributions menu. So we're going to do the first inverse normal that we had talked about, and we are going to be doing that for the 0.04 probability. So I'm going to do second function, and I'm going to find the distributions menu, which that, by the way, is the variables key, second function of the variables key. And then I'm going to use this inverse normal. So the inverse normal, what it's looking for is first to input the area under the curve. So I want 0.04. And then the next thing I want is the mean and the standard deviation, 0 and 1, and then I want to go ahead and paste it. Now this calculator of mine has the newest operating system on it, which gives you a step-by-step introduction into what you're supposed to be using. So now I put enter, and that's what it's going to look like. If you have the old operating system, you actually have to know exactly what to put in. And then I go ahead and I hit enter. And you see that I get a probability of negative 1.7506866071, which rounded to two significant digits, three significant digits, the negative 1.75 that we would get from the normal table is exactly the same value. So let's do that one more time, at least. Let's do it now for our example where we were looking for the lowest or the highest 17%. Now let's say we just wanted the highest 17%. If I wanted just the highest 17%, I would actually have to do the compensation of looking for lower, because the inverse normal is set up with the lower tail. So I would have to do 1 minus 0.175. And then I would have the 0.825. Now that is what I want to put into my inverse normal. So my inverse normal is 0.825 and 0 mean and 1 standard deviation, and I want to paste that. So there we have the inverse normal for 0.825 with a mean of 0 and a standard deviation of 1. And that one gives me the 0.934589, which rounded to two significant digits here is 0.93, the same value that I got in my standard normal table. Now look at what happens if I do an inverse normal for the 0.175. 0.175 area is on the left side of my curve. So, oops, I missed my inverse key. So I have that, and if I put in 0.175, what you're going to notice is I'm going to get the same exact value, but it's going to be a negative z. Oops, that is not what I wanted to do. So I'll quit that and I will try it again. Second function, distributions, inverse normal, there we go, paste that in, and now enter. And now you see I have exactly the same value there. The inverse normal for 0.825 and the inverse normal for 0.175 are exactly the same number. They're just opposite signs, because as we talked before, they're on opposite sides of the equal sign. So that's how we use our calculator in order to find these inverse normals. The inverse normal on our calculator still only gives us the area in the left-hand table, or tail of the distribution. It cannot be used in any other way. That it always must be compensated for the left tail. Now in my class, even though you can put in a standard deviation and a mean of any normal distribution, I will not allow that. I will be making it a requirement that you unstandardize using the x is equal to the mean plus or minus the z times the standard deviation. So you should just always be using a 0, 1 for mean.